This is Euclid Book 9, proposition number 36, and yes, Euclid definitely saved the best for last. As you can see, this is one thunder of a monstrosity here. I mean, this is huge. And yes, we will be using real live numbers this time. Okay, I know in some proofs I haven't done that, but this one, it's required. Okay? So, let's get into this, shall we? If as many numbers as we please, beginning from a unit, be set out continuously in double proportion until the sum of all becomes prime, and if the sum multiplied into the last makes some number, the product will be perfect. For let as many numbers as we please, A, B, C, and D. Now here we go. We got A, B here. This is A and B. This is C. This is D. Okay. Beginning from a unit, be set out in double proportion until the sum all becomes prime. Now, first of all, we're going to be talking about perfect numbers here. We're going to show you a perfect number at the end of this. Alright. So, how does this work, okay? We have a unit, and it's 1. And 1 multiplied by 2 is going to be 2. That's going to be A right here. And 2 multiplied by 2 is going to make 4. That's going to be B right here. 4 times 2 is 8. That's going to be C. And 8 times 2 is 16. That's going to be D right there. Okay. And let E be equal to the sum. Now, what is E going to be? Well, what is 1 plus 2 plus 4 plus 8 plus 16? Well, it's going to be 31. That's E. And let E, by multiplying D, make FG. E times D, which is 31 times 16, 31 times 16, of course, is going to make FG. Well, 31 times 16 is going to be 496. We're going to say that FG is perfect. For however many A, B, C, and D are in multitude, let so many E, H, K, L, and M be taken in double proportional beginning from E. So what we're going to do is going to say E is the start of it, okay? HK is going to be double of E. Okay, so E times 2 is going to be HK. HK times 2 is going to be L. And L times 2 is going to be M. Now what is 31 times 2? That's going to be 62. What is 62 times 2? That's going to be 124. And what is 124 times 2? It's going to be 248. You say, well, I don't believe you. Okay. There you go. Check it out for yourself. Alright. Let's go on here. Therefore, xi quali, as A is to D, as 2 is to 16, so is E, which is 31, is to M, which is 248. Okay? And this is by Euclid Book 7, proposition number 14. Therefore, the product of E and D, well, what's E times D? Well, 31 times 16 is, of course, 496. And we can say that A times M, which A is 2, M is 248. 248 times 2 is also going to be 496. And that's by Euclid Book 7, proposition number 19. And the product of E and D is FG. E times D is FG, which is 496. Therefore, the product of A and M is also FG. 2 times 248 is 496. Therefore, A, by multiplying M, has made FG, which we just said. Therefore, M measures FG. M is going to measure FG according to the units in A. Okay? So, M measures FG, which 248 measures 496 twice. And A is a dyad. Well, a dyad is a pair. This is a pair of units. And a pair of units is 2. Therefore, FG is double of M. FG is twice as long as M. 496 is twice the number of 248. But M, L, H, K, and E are continuously double of each other. Okay? So, 31, 62, 124, 248. You can see that that HK is twice the size of E, L is twice the size of HK, and M is twice the size of L. Therefore, E, HK, L, M, and FG are continuously proportional in double proportion. Okay, here we go. 31, 62, 124, 248, 496. Do the math. Now let there be subtracted from the second HK and the last FG. Okay, so we're going to subtract a number from HK, and that number is going to be HN. And we're going to subtract the number from FG, which is going to be FO. Okay? FG, FO. And each one is going to be equal to E. So HN is equal to E, which is 31, and FO is equal to E, which is, of course, 31. Therefore, as the excess of the second is to the first, so the excess of the last to all those before it, which is Euclid Book 9, proposition number 35. Therefore, as NK is to E, as 31 is to 31, so is OG, this is OG, is to the sum of, okay? We add 248 plus 124 plus KH, which is this right here, which is 62. So 248 plus 124 plus 62 plus E, and if we add all those numbers together, we're going to get 465. Okay? And we'll also get 465 when we take the length of OG. Now, NK is equal to E. We've already established that 31 is equal to 31. Therefore, OG, which is 465, is equal to the sum of 248 plus 124 plus 62 plus 31. But FO is also equal to E. Okay, so 31 is equal to 31. And E is equal to the sum of A plus B plus C plus D plus the unit. So you have 1 plus 2 plus 4 plus 8 plus 16, which is 31. Therefore, the whole FG here, this whole length right here, is equal to the sum of, here we go, 31 plus 62 plus 124 plus 248 plus 2 plus 4 plus 8 plus 16 plus 1. You add all those numbers together, and that becomes the length of FG. And it is measured by them. A measures FG, so does B, so does C, so does D, so does L, so does E, so does M, and so does HK. I say also that FG will not be measured by any other number except A and B and C and D and L and E and M and HK. No other number will measure FG than any of those. And the unit will measure it too. Okay? 1 will measure anything. For if possible, let some number P measure FG. Now we're going to say hypothetically that P measures FG. And let P not be the same with any of the numbers A, B, C, D, whatever, whatever, whatever. So in other words, P will not be the same length as A, nor will it be the same length as B, or C, or D, or L, or E, or M, or HK. P will be its own length. And as many times as P measures FG, so many units let there be in Q. So let's say that P measures FG twice. Well, that would make Q 2. We're not saying that, but let's say hypothetically that was true, then Q would be 2. Therefore, Q, by multiplying P, has made FG. But further, E also has, by multiplying D, made FG. So E times D makes FG. And we already established that 31 times 16 is 496. Therefore, as E is to Q, so is P is to D. That's by Euclid Book 7, proposition number 19. And since A, B, C, and D are continuously proportional beginning from a unit, therefore D will not be measured by any other number except A, B, and C. So in other words, the only numbers that will measure D is A, B, and C. Those are the only numbers that will measure it. This is by Euclid Book 9, proposition number 13. And by hypothesis, B is not the same with any of the numbers A, B, and C. So P is not the same length with this, or this, or this. Okay? Therefore, P will not measure D. P doesn't measure D. But as P is to D, so is E is to Q. Therefore, neither does E measure Q. E can't measure Q. This is by Euclid Book 7, definition number 20. And E is, of course, a prime number. And any prime number is prime to any number which it does not measure. Okay? So, if E doesn't measure Q, then E is prime to Q. This is by Euclid Book 7, proposition number 29. Therefore, E and Q are prime to one another. But primes are also least. This is by Euclid Book 7, proposition number 21. And the least numbers measure those which have the same ratio, the same number of times, the antecedent to the antecedent, and the consequent to the consequent, which is by Euclid Book 7, proposition number 20. And as E is to Q, so is P is to D. Therefore, E measures P. E is going to measure P somehow. And it's going to measure it the same number of times that Q measures D. Okay, so E measures P the same number of times as Q measures D. But D is not measured by any other number except A, B, and C. These are the only three numbers that can measure D. Therefore, Q is the same with one of the numbers A, B, and C. Now we're going to say that Q is one of these. Now we're going to say hypothetically that Q is the same length as B. And however many B, C, and D are in multitude, let so many E, H, K, and L be taken beginning from E. Now E, H, K, and L are in the same ratio with B, C, and D. Therefore, xi quali, as B is to D, so is E is to L. As B is to D, so is E is to L. And this is by Euclid Book 7, proposition number 14. Therefore, the product of B and L is equal to the product of D and E. So, B times L is going to be the same as D times E, which in this case, E times D is 496. So now we're going to say that B times L is also 496, which of course is not true. Euclid Book 7, proposition number 19. But the product of D and E is equal to the product of Q and P. Okay? D and E times each other is equal to the product of Q and P times each other. Therefore, the product of Q and P is also equal to the product of B and L. So now we're saying that Q times P is equal to the product of B times L. Therefore, as Q is to B, so is L to P. This is by Euclid Book 7, proposition number 19. And Q is the same with B. Okay? Q is the same with B. So that means these two are the same length. Therefore, L is also the same with P. Now we're saying that L is the same length as P, which of course is impossible, but by hypothesis, P is not the same with any other numbers set out. So in other words, we said that P was not equal to L, but yet it is. That doesn't work. Therefore, no number will measure FG except, so no other line will measure FG except A, B, C, D, L, E, M, and HK. That's the only lines that will measure FG other than the unit. And FG was proved to equal the sum of A plus B plus C plus D plus L plus E plus M plus HK plus unit. And a perfect number is that which is equal to its own parts. This is by Euclid Book 7, definition number 22. Therefore, FG is, of course, perfect. And that ends Euclid Book 9 forever. When I start this again, we will be in Euclid Book 10. I will tell you more in a future definition. I will tell you more in a future video. Stay tuned.